Today we're going to look at CMO Status Example number 1. We'll initialize a CANopen network. We will also initialize a drive and look at initialize extended. So today here I have a Copley STP connected to a stepping motor with encoder. This is going to be open loop microstepping, 4,000 microsteps per rev to match my 4,000 count per rev encoder. This has all been set up and tuned with CME2. The drive is disabled, blinking green. We can also see the CAN status is blinking red because the CANopen master has not been connected yet. I have a 120 ohm terminator. I have RJ45 Cat5 cable and RJ45 to 9-pin D-sub adapter, the Copley USB to CAN adapter. I checked this out with CANview to check the network, and it looks good. There's a terminator at this end, so both ends of the network are terminated, and this goes and plugs into the laptop. So first we're going to look at CME2 just to take it. So I'm connected with the USB to RJ11 serial connector to the serial port on the drive, and I'm running CME2 version 7.1 beta. And I'm going to take a quick peek at the node address switch is set to 1. I can see the address is 1. It's in a pre-operational state. The mode of operation is CAN stepper. That's good. It's software disabled. That's because the master hasn't enabled it yet. It looks like I'm all ready to connect over CAN. So let's run the example. So I installed CMO and I've got the examples here. There's a VB.NET Status Example 1, and here's the Visual Basic project file. So I previously installed Visual Studios, and it's going to open up the example. So I get this form for checking the status, and I can try to run this form. Double click on it and you'll see the code behind it. And I'm going to hit play to run the form, but I get this error message, access denied. And so there's a problem right away just with the start of the program. So let's take a look at the program here. We can see a little description of what's going on with the CAN. We have x-axis set to node 1. That's good. I've got the node address. Dimensioning a CANopen network, dimensioning an x-axis amplifier. That's good. When the form loads, it tries to initialize the code here. So this creates the x-axis amp object and the CANopen object. The CANopen bit rate 1 megabit. I believe that to be good. Copley 0. That's the Copley interface. CANinitialize. Well, that's good. And x-axis amp initialize, pass it the network and the node ID. It should initialize. So I'll take a look with CME2 and see what the problem is. I'll use the communication wizard and try connecting with CAN. No CAN devices were found. Well, there you go. I got to unplug my mouse and plug in my CAN device. So now it finds Copley channel 0, 1 megabit, perfect. And it can connect to the drive. You see we have a status is green, no red, because there's something talking to the drive. It's still in a pre-operational state. It's blinking green. When it's in operation, it'll be solid. But we can't leave this like this, so we're going to have to turn off CME2 so that we can run the program. So let's try running the program again. There we go. So what happened here in the code was it did the CANinitialize, and then it got a catch try. So there's a try loop here. So it tried this, and then the try catch displayed the error message. So that's how we capture the event of, you're not plugged in. So we can enable and disable the drive. We can read the event sticky. So when you read an event sticky, it goes away after you read it. If we had CME2 connected over the serial port, we would be reading the event, and then the software CMO wouldn't be able to read it sticky because it already got read by CME2. So again, as long as the event is in existence, you can read it. After it goes away, you can read it once. The second time you read it, it's sticky, so it gets cleared. Just a little note on the example here, besides enabling and disabling the drive, x-axis amp.disable, x-axis amp.enable, we can look at the sticky events. So this is a CML event status, and it's an enumeration which comes back with a number. These are events in the drive. There's more events, but these are typical events that we see happening. You can write your program so that you try to read all the events. Something happens. I try to home. I try to make a move. I get a catch try. Oh, well, let's see what happened. The brake was on. I got a fault. I hit the limit switch. So in your program, you can try to capture events. So now we're going to look at the initialize. The defaults for the initialize is the network and the drive, and of course it enables the drive and holds position. And there's a lot of defaults that go on. So maybe we don't want to use the defaults. So we'll take a look at the CMO Programmer's Guide and initialize extended. So in our program, we'll have an amplifier, initialize extended, and there's a parameter called ampSettings. So let's take a look at all the ampSettings. ampSettings.enable on init equals false. So we're going to initialize the amplifier, and when it goes into the operating state, it will not be enabled. So we can see that there's the ampSettings object contains guard time, heartbeat. This is all the node guarding parameters. You can reset on init, enable on init. This could be the sync producer. I'm not going to mess with that now. Timestamp. So an amplifier initialization extended. There's a bunch of parameters that we can adjust. We'll take a look at that. So I'm going to start by commenting out the initialize, and I'm going to add an ampSettings. So dimension and ampSettings is an ampSettings object. Create an ampSettings object. Change the values of the ampSettings object. So enable on init is false, so it will not come up enabled. I can initialize it in a servo CAN profile mode. That's if I got a stepper drive set up in a servo mode. So you can specify the mode of operation on the amp init. I don't want to reset, and I'm setting my heartbeat and guard times to 0. Trying to get away from the node guarding error when the CAN cable gets unplugged. But these values should be set to reasonable times based on what your operating system can do. And it would be nice if Windows could pay attention to the drive at least once every 200 milliseconds. There should be sync messages sent out, and the master should be sending and receiving data. If you pause your thread and you're not sending any messages, then you'll get an SDO timeout, and you'll see that in the drive as a command input fault. But let's go ahead and run this and see what we get. So this time the drive is disabled on init. Oh, I got to fix the button here, but my code is backwards. So I got the event is constantly on. I keep reading it. It keeps getting set. So read it sticky, keeps getting set. It's disabled. I press the disable button to enable. And there we go. So I had to toggle through the switch to get it to enable. And then read sticky, it's gone. So now the drive is enabled, and it's an open loop mode right now. So I can't turn the shaft. There was some other events, but we didn't enumerate them, so we couldn't see what they were. It's interesting. So we have to figure out what 128 is. So 128 is bit 0, 1, 2, 3, 4, 5, 6, 7. Bit 7. So looking at the software, not all events are included. See documentation. So let's see. Event 7 is current limited. So we can add this. So I did another if then dot and current limited. Alphabetical is nice. And don't forget to change your message. Current limited, that's a good message. So we can run the program now. Enable the drive. Turn the shaft. Get an event. Read it sticky. Event status, current limited. So the other events are gone. The drive's not disabled. The only thing that's remaining is the current limited. That's the value right now. When we disable, we can see the event and it's sticky, so that read it. But these are ongoing events. So ongoing events are not sticky. Once you read an event, read it sticky, it goes away. So I've pulled the CAN connection, and I got a blinking light here that's on the status indicator. And as I ran CMO, it was running just fine, but then an error occurred. It was unable to talk to the drive, so it timeout CMO. So that's not a lot of detail. Now we can take a look at the drive with CME2 and see what it says. So if we look on the control panel, I'm connected over the serial port now. I can see, I'm in a CAN mode. It's not a stepper, it's a servo mode, because that's what I put it in. And I also have a disable, and I have a network status limit warning. So after a while, when the slave doesn't see messages, it goes into this warning mode, and the drive becomes disabled. So transmit error passive. This is just saying, hey, I haven't seen any messages for a while. So it's it's in an operational state, but it's disabled. So what I'll have to do is reconnect the CAN network. So let's hope that's under serial control here. So let's hook this back up. Status light's good for the CAN. Drive's disabled. Let's try retry on the timeout. There you go. Everything's good. I can enable and disable the drive. Turn the shaft of the motor. See some actual counts. And read the sticky events. Okay. Thanks for watching Status Example and InitializeExt. And we'll do each example one at a time. Thanks. Bye.